Okay, so now we are continuing with section 5.3, 5.4. So today we are going to discuss the graph of tangent x. So remember, f of x is equal to tangent x is also equal to sine x over cosine x. So you see now that we have like a fraction. We cannot say this is rational function because rational functions are the ones in which the top and the bottom are polynomials. So, but this is like a fraction form, so it means we can expect vertical asymptotes, and we can expect the zeros from the top and vertical asymptotes from the bottom. But as we discussed or mentioned earlier, these trig functions are periodic functions. So tangent also is a periodic function. It will repeat its values after a certain interval. What is that interval? So what is the period of the tangent function? So recall from section 5.2, we notice that if we have tangent of x plus pi, then we will get back the same value that we get for tangent x. For example, tangent of pi over 3 is square root of 3, and pi over 3 is in the first quadrant. Now if you do pi plus pi over 3, which is equal to 4 pi over 3, is in the third quadrant. So the tangent of 4 pi over 3 is also square root of 3. So this is why we say that it repeats after every pi interval. So that we say that the period of the tangent is pi. Okay. Now as before, we will start by graphing the, so actually we can graph the tangent function at any period. Okay. For example, we can go from 0 to pi, pi to 2 pi, so on, or we can go from negative pi over 2, pi over 2, and then pi over 2 to 3 pi over 2, and so on. So we prefer the second form because we see that there will be asymptotes. Okay, let's see how we get the values of the tangent. Some values that we know already. So then pi over negative pi over 2, the sine is -1 and cosine is 0, and we say that the tangent is undefined, so there is no value we can say exists at negative pi over 2. The negative pi over 4, the tangent function has value -1 because of sine is negative square root 2 over 2 and cosine is square root 2 over 2. Now the value at 0, tangent is 0, and then pi over 4, where the value of tangent is 1, and pi over 2 again is undefined. So undefined means at the pi over 2 we don't have a value, but whatever, like to the left of pi over 2 and to the right of pi over 2. Okay, so we will talk about left of pi over 2. So as we go from left to right, we get closer and closer to pi over 2. Now what is pi over 2? Pi over 2 is, pi is about 3.14, some other values. Pi over 2 will be dividing pi by 2. So here is the values: 3.141596 pi up to 1, 2, 3, 4, 5, 6, 7 decimal places. Divide by 2 and we get this value. This is pi over 2 approximated value. So if we get closer, so if we try to find out tangent of x at 1.5 using a calculator, we get this value. If we get even closer, 1.55, we get 48.08. We get closer, 1.57, we get 1255.77. So you notice what is happening as we are getting closer and closer to pi over 2. The value of tangent is becoming larger and larger. So this is what we say. We say as x gets closer and closer to pi over 2, the value of the tangent x gets bigger and bigger, and we write it as like this. We read it, we read as tangent x goes to plus infinity as x goes to pi over 2. In the same way, we say tangent x goes to negative infinity as x goes to negative pi over 2. You will notice if we go to negative pi over 2 with the values from the right, you will see that you get the bigger and bigger negative values for tangent. Okay, so coming back to the left now here, what are the zeros? So again, as I said, we are only going to look at this in the interval negative pi over 2 to pi over 2, this interval. Why not including this? Because tangent is not defined at pi over 2 and negative pi over 2, so we don't have square brackets like we had for sine or cosine. The tangent is sine x over cosine x. Setting it equal to 0 means numerator is 0, sine x is 0, 1 is sine x 0 in the interval, this interval only at 0. Now, BS vertical asymptotes we will get when cosine x is 0, and in this interval, the cos x is negative pi over 2 and pi over 2. These are the asymptotes, vertical asymptotes. So here, I've drawn this. Now the function takes on the value 0 at 0, and when we get closer and closer to pi over 2, we are going up and up here. And when you get closer and closer to negative pi over 2, you'll get down here. So the function little like the graph of the sine x, but not, this does not get flattened here, okay, at the 0. The sine x becomes a little bit like flat. This one, so sorry, the cube, x cube, but tangent x is just like this. So now what? So this is one piece, now repetition. So every odd multiple of pi over 2, there will be an asymptote. So this asymptote is as pi over 2, the next one on the right will be at 3 pi over 2. And the piece is similar. So if I don't go up to the next asymptote, if I want to stop here, then the piece in this portion will be like only the bottom piece. And on the left as well, the next on the left, negative pi over 2 is the asymptote. The next one on the left will be negative 3 pi over 2. And in between, the function will behave the same way and so on. And this is how we graph the tangent function. Okay, now remember the period here, the period of the tangent x is pi. So if you have the function tangent dx, then the period will be pi over b. Pi over b. So here you see we have tangent 2x. So period is, okay, let's say the period will be pi over 2. So that what do we do now? To graph the function, remember, so period is pi over 2. There is no amplitude here. So this is what you will do. You will divide pi over 2 by 2. It gives you pi over 4. So now take a little, big enough space, and this is pi over 4. This is negative pi over 4. So these are going to be in place of the pi over 2 and negative pi over 2. These are going to be the asymptotes. This will be the graph passing through 0. This is the graph of tangent in one period. If the question doesn't mention the period, then you should show a couple more pieces. So if this is pi over 4, you can see this distance between the two asymptotes is pi over 2, which means we should be able to find the next asymptote at a distance of pi over 2. So pi over 4 plus pi over 2 will give you 3 pi over 4. You just go at the same distance, this much, and put right here 3 pi over 4 and draw the asymptote, and then center will be pi over 2. And the other side also, this will be negative 3 pi over 4. Center will be negative pi over 2. Now, this is how we go with the half of the tangent. Okay, let's look at this last example here. So here B is 2 pi over 3. So B is 2 pi over 3. So that period will be pi divided by 2 pi over 3. What will this become? Pi times 3 over 2 pi. Pi and pi get cancelled. We get what? 3 over 2. So the period is 3 over 2. What do we do? Divide 3 over 2 by 2. We get 3 half, 3 over 4. So the same thing that we did before. Your y-axis, x-axis, somewhere here, 3 over 4. And here, negative 3 over 4. Vertical asymptotes. this much distance is 3 over 2, that much distance over here, another asymptote. And what will be the number that will go here? Well, add 3 over 2 to the number here, 3 over 4. So 3 over 4 plus 3 over 2 is going to give you, the denominator will be 4, 3 plus 8, 11 over 4. Center will be, the center, remember I told you how to find this midpoint. Well, you have 3 over 4 plus 11 over 4. 3 over 4 plus 11 over 4. Add them, you get what? 3 plus 11 is 14. 14 over 4, which is what? 7 over 2. And then we divide it by 2. So 7 over 2 divided by 2 is 7 over 4, which goes in here. So this is how you will draw the tangent. Oh, by the way, I forgot one thing. We have to flip it because of this negative sign, and then we have to move it 2 units up. So flipping it, okay, so I will use a different color now. Flip and move up. If this is 1, this is 2. So I will draw a dashed line at 2. And move all these values here. The asymptotes will just stay, so whatever, wherever, you know. Now the actual graph will look like. Okay, now erase this. That's why if you use pencil, then it helps. This is how the actual graph. Now where is it crossing the x-axis? Well, it will not be that easy for you to find because you cannot do that without the calculator. But now it will be passing, it's kind of, its 0 is related to this line at 2. That's how you do the tangent. Okay, so that's it. That's end of 5.3, 5.4.